but not.
It only took them 2 years.
I know, right? It hasn't. No, that's the old one. I'm saying like it's in the building. It's not on the wall. All right, this is 72. Stay with me, y'all. Good test grade this Friday. Let's see the difference. Change something in your work ethic. Change something, okay? Lifestyle changes don't happen with drastic changes. Change one thing. Are you paying more attention? Are you taking more notes? Are you listening better? Are you trying harder? Change something, and I promise you're going to see a change in your grade. We are looking at exponential functions still. The last 2 weeks, we have been exploring what an exponential function is. What was the real-world example that we started with? It was an activity. Do you remember? What was the real-world example that demonstrated an exponential function? What is it? So the person doing 3 good deeds, and then those people carrying 3 more good deeds, it multiplied exponentially, right? Instead of it just being 3 people each day, it ended up being 3, then 9, then 3 times 9, 27, and then 81, and so on. So that was exponential. Then we explored the graphs of exponential functions. We talked about the characteristics of them. And then we looked at how to type it in Desmos, how to get the table in Desmos, how to get the decimals to fraction in Desmos. Now what we're going to look at is how to write the exponential function, how to write the equation from either a table, a graph, or a word problem. There are 3 categories on this paper. I'm going to walk you through all 3 categories, and then I'm going to turn you loose on your practice assignment. We do have a couple of things to take care of. First of all, this should look familiar. A times b to the x power. That's your exponential function formula that's on your EOC formula sheet. Which one is the starting value? Do you remember which letter? What's the start of the alphabet, y'all? So what's my starting value? A. Come on. Why is this not reading? Then the common ratio or the multiplier is your base. Exponential functions change by a constant ratio, okay? The multiplier has some secret code words, and they're not really that, top secret, because if I say double, what does that mean? What number implies if I say double? Times 2, right? What number is implied if I say tripled? What number is implied if I say halved? 1/2. Now, if we have a percentage of increase, it would be the 100% plus the percentage of increase, right? Because it's increasing. So if it has a growth of 25%, if it's growing by 25%, then you have the 100% that's already there plus 25% in growth. Now, if it's decreasing, then it's the 100% minus the percent decreasing, okay? Great question. Why do we put 1 and not 100? Your answer starts with a P. Huh? Yeah, it has to do with percentage. What does 1 represent in percentage? 1.0 as a percentage. 1.0 as a percent. Do you remember how to do percent, y'all? So this is, as a percent, 100%. As a decimal, it's 1.0. So 1.0 is 100%. 0.5 is, careful, 50%. 0.05 is 5%. Right? Real quick, remember that? So you move the decimal to the left 2 times because you're dividing, you're saying 50 divided by 100 is 0.5. Over here, you're multiplying by 100. It depends on which direction you're going. Okay? If you're going to decimal, you divide by 100. If you're going to percent, you multiply by 100. I guess you could think of it this way. If I'm going to a decimal, I'm going to divide, and what do those both start with? Yeah, so maybe that'll help. If it's a percent form and I'm going to decimal, I divide by 100. And then that way the other direction is multiply. Okay. Let's look at this. We're going to learn how to write the equation from a table first. This would probably be the easiest. And you might be thinking, how in the world? Let's look right here. To write the exponential function from a table, you're going to identify the common ratio and then identify the starting value. Your common ratio is your base. Your starting value is your A. Here's where I feel like I'm crossing an ethical line to show you this hack in Desmos. It's crazy that they're allowing this, but they are, so we're going to use it because obviously they know that they're allowing it. I need you to go to Desmos and I need you to create a table like number 1. Just create a table. So we don't have an actual function yet. We're entering the table. So you go here and hit table. We got 0, 2. Then what? 1, 6. 2, 18. What's the last one? 3 and 54. You should also notice that as you're plotting these points, do you notice that they're putting them on here for you? Look at that. Now, remember that day we played around with the settings on here. Like this is way too much x-axis. So I'm going to go in here and tell it, hey, I really don't want to see all this x-axis because it's kind of hard for me to see this exponential curve. So I'm going to go in and tell it this. I'm actually going to cut that even smaller. Because now look, now I can actually see that curve. So like compare this. See, this is the home button, right? Can't see but the 2 points. If I zoom out, I really don't see a curve. This looks like a straight line, wouldn't you agree? This looks like a straight line. Go over here to the settings on the graph. Ask yourself, which axis do I have way too much of? And it would be the x-axis. I have way too much x-axis. So I'm going to tell it, hey, I really don't need this much over here on the left. Maybe -1's fine. And on the right, like, look, this was 20. I'm just going to play it by ear. This is still too much. Like, this is all the way over here. So I'm going to tell it, never mind, just stop at 10. And now, do you notice, like now I actually see that curve. This no longer looks like a straight line. Do y'all see that? Is everybody to this point? You have the table and you have an adjusted graph. If not, lean to a neighbor. I really hope I didn't put that ring on. It's not on my finger. My grandmother's ring. Maybe I didn't wear it today. All right, y'all good? Because I'm not. Now watch this. Here's the hack. You ready? It's It's going to go by so fast, you're going to be like, I didn't even see it. You're going to go to the next line. You're going to tell Desmos to give you the equation of the curve that passes through those points. Now, here's the problem. You have to know what type of curve is it. You have to know if it's linear, quadratic, or exponential. Well, if you had it set to that home setting, it looked linear, right? You need to adjust it to where you can get in here and you can actually see, okay, this is not a line, this is a curve. Is there another part of the curve over here? There is not, so it's not quadratic, which means it's exponential. You've only learned 3 types. You've got linear from 8th grade, you learned quadratic in Unit 4, and now we're on exponential. So there's only 3 possible outcomes. So here's what we're going to do. We're going to tell Desmos, okay, I need you to give me the exponential equation. Here's how you do it. You see up here it says x sub 1, y sub 1. We have to use those exact names. So you can't just enter y. You have to enter y sub 1. So if you type the 1, it will default down like that. Now, what's the formula for an exponential? Let's go over here. Look, what is it? Y equals what? A times b to the x. So here we go. All right, now don't put an equal sign. Here's the trick. If you watch what happens. If I hit y equals a, don't type this, just watch, times b to the x sub 1, it's not going to give me anything. Do you see that? Watch when I change that equal sign to what's called a tilde. It is called a tilde. It is the top left of your keyboard. It is the squiggly line. It's called a tilde. Gavin, are you with me? That tilde means this. Give me the equation that fits the points. That's what that means. It's called a regression. Regression is the fancy math word for give me the equation that fits the points on the graph. You're telling Desmos, I need it in exponential form, and I want you to give me the equation or the parameters. Now watch this. You're going to check this box, because if you check this box, it gives you what's called your regression coefficient, which comes in handy when we get to statistics, okay? Right now, just check it. All right? What do you notice it says for A and B? 2 and 3. Now, let's check our answers. Come down here, and let's graph the equation where A is 2 and B is 3, and let's see if it overlaps this graph. Here we go. Y equals 2 times 3 to the x. Bam. So that's the equation of the curve that fits that table. Please put it on your paper. Y equals, or f of x equals 2 times 3 to the x powered. Now, let me explain the math behind it. You see how this is counting 0, 1, 2, 3? Okay, come over here. Look at this. How do you get from 2 to 6? Multiply by 3. How do you get from 6 to 18? Multiply by 3. How do you get from 18 to 54? Times 3. That's exactly why 3 is right here. And then what is your initial value? Well, that's when x is 0. So what is it? 2. So I need you to learn how to recognize on the table, this is my initial value because x is 0. The initial value is at x equals 0, and it's the number 2. And then this is my b value because they're increasing by a multiplication of 3. I would like you to try number 2.
So you're going to go in and you can clear this out. You can leave this here, but I honestly would clear it out and practice typing it. Because on the EOC, we cannot tell you, you can't raise your hand and say, Miss Holcombe, what was that hack on getting the function? You can't do that, okay? So I would clear it out and practice typing it so it commits it to memory. Dakota, are you with me? Because I don't see you really moving much. So I would take this out and I'd come up here and then clean this. What is it, 1 and 40? 2 and 20? All right. We don't have to adjust our graph much because we can already see there's a curve. Now you're going to tell Desmos, yes. You're talking about the third? Are you talking about right here? No, like when you put when it puts the line. Because this is not giving me the equation. Oh, so if you put the line on there, it gives you the equation. Yeah, like if I type y1 tilde, I've just told Desmos, give me the equation of the line. And then you have to tell it what format. So I've got an exponential, so it's a times b to the x1. And then bam, there it is. A is 80 and b is 0.5. Now if you need to come over here and say to yourself, what is 0.5 as a fraction? You should know that, but you can do that. You can type it right here to get the fraction. Because I don't know on the EOC if it's going to be in decimal form or fraction form. Then you can also say, okay, I'm going to type it now to see if it's right. You really don't even have to type the y equals. Watch this. 80 times 1/2 to the x power. Do you see how, watch, I'm going to take it away. Now watch the graph turn blue because it just overlapped, which showed me that I have the correct answer. So now you're going to copy that to your paper over here. Well, if it just doesn't have to be blue. It's just a matter of that it has just graphed another graph and it's superimposing on top of the table's graph, which means it's right. So this was, oh my, there she is. Hold on. All right, so this is 80 times 1/2 to the x power. Because notice right here, how do you get from 40 to 20? You multiply by 1/2, which means it's shrinking, right? 20 to 10, multiply by 1/2. 10 to 5, multiply by 1/2. Does this table show me the starting value? Does it show me the starting value? No. You'd have to know which direction it is. Is it here or is it back up here? It would be right here, right? Because this needs to be 0. So you'd say to yourself, well, if it was 0, I'd be going in reverse. Instead of times 1/2, I'd multiply by 2 so I can see that it's actually 80, right? All right, try 3. Hey, come on in. All right, what's the table? 0, 1200. 1140. Y'all do number 3. All right, you're good. 2, 1083. What was the 3 value? 1028.85. 1028.85. All right, and then 0.95 as a fraction. There you go. So it'll take either. You need to be able to do both. Fraction and decimal. Wait, which one are you on? Oh, okay. Hold on one second. So for this one, we got 1200 and then 0.95. So it's 1200 times 0.95 to the x power. I'm recording. 19/20 to the x power. So there's 2 ways to write it, right? If you're talking while I'm trying to teach, then that would be an example of a will problem. Okay, now let's look at it. What if I give it to you as a graph? Well, first of all, take what you learned in the last 2 weeks. Where is the asymptote in the function? No, I mean like in the equation. Where does the asymptote always appear in the equation? At the end, right? Just like your asymptote is at the end. Okay, anyways, write the exponential function from a graph and create tables. It says only include a c value if it's not 0. I don't have a problem with you including a 0 as the c value to confirm, okay? So let's look at this. Quit. This is 1, and then you'll notice this is a and this is a times b. They are not giving you actual numbers here. We don't actually know what this y-axis is. This was just trying to generate your your generic function. So it's going to be your starting value, which is where it's crossing the y-axis. This is your initial value where it's crossing the y-axis. So in this case it's a. And then now the gap, the rate of change from a to a times b. What's the difference in them? What did a get multiplied by to land here? B. So it's b to the x. And then technically it's plus c. And this is your asymptote, okay? Yeah. Here the asymptote is 0. So this would technically be 0. But I'm putting this here as kind of a formula for you as you do these two. Okay?
Please excuse the interruption. This is for all sophomores. All sophomores. Please check in with your flex teacher and then immediately report to the theater for the Johnston classroom presentation today. You will eat lunch afterwards. Sophomores, please bring either a pen or a pencil to this presentation. Please bring a pen or pencil to this presentation. Teachers, please review the master schedule for this presentation. And teachers normally have third lunch. Will need to have second lunch today. Teachers who normally have third lunch will need to have second lunch today. Thank you.
Okay, you're looking for 2 things. We need the initial value. 3 things. We need the initial value. We need to know What did it get multiplied by to go from one point to the very next point? The next point, right? Not from this point to this point. That's not helpful. It's got to be the very next point. And then you also need to know the asymptote. What's the asymptote here? 0. So C is 0 here. Where's it crossing the y-axis? Huh? It's crossing at 5. You've got to ask yourself, this is 5, and then the very next point over. Now you can look at these right here. The reason, can you tell me why I avoided these points? They're not pretty, so I have no clue what they actually are. You need the pretty integer points, the ones that cross the grid at whole numbers, okay? This is 5. The very next point over shoots up to what? What's the y value? 10. How do I go from 5 to 10? What did I get multiplied by? I multiplied by 2 to land here, right? So that's your b value. So here we go. We've got an initial value of 5, and then we're multiplying by 2 to the x, and then we technically don't have an asymptote, so you could put plus 0 here to confirm. But then I would go to Desmos and I would enter that function and see if it mirrors this graph. Ugh. All right, come over here. Let's try this one. Pull pretty points. This is really hard to see. I think that one's pretty. But this looks like, is it counting? Does that say 2, 4, 6? No, I can't tell. Is it 3, 6? Okay, so this is 6, right? So this is y-axis, that's A. A is 6. Let's find another pretty one. Looks like this one's pretty. This is 24, maybe? Okay, now make sure they're like, you know, right next to each other. This was 6, and then okay, here's where you have to be careful. If you put a runner on this graph, what's it doing? It's going down, which means we're decaying, which means it's not times 3, it's divide by 3. So you do have to be careful with the way that you look at these points. Start from the left and go to the right. This is at 24, and it's shrinking down to 6. So what did it get divided by? 3. Now you don't write divide 3. You have to think of it as a ratio. So it's times 1 over 3. I know. So this is 24, and it's shrinking, it's multiplied. So this is 24 times 1 over 3 to shrink down to the 6. Not 3. Is that an 8? Is it a 6? That's a 4, isn't it? Wait a minute. If this 24 is hard to read. Is this 24? Yeah. And it's shrinking down to 6? Yeah. So 24 divided by what gives you 6? 4. Well, because it's 1/4. Yeah, because it's, remember, there's nowhere to write this equation, so I guess I'll write it right here. So this would be number 3. F of x equals, we got A times B to the x power. What's our asymptote? Technically it's 0, but you don't really have to write. So I guess you need to make a note to yourself, like, watch out for decay. Decay is harder because it should be a fraction less than 1. Now, what if I give it to you as a word problem? You would think, oh, this is harder. I would say this is actually easier. I would say the graph is the hardest. So let's look at this. Austin's doing a lab experiment in his biology class. He puts 2 bacteria cells in a petri dish and waits to see what happens. In 1 hour, the number of cells quadruples. Write an equation to represent the situation. How many did he start with? He starts with 2. A is 2. What is the rate it's growing? Times 4. So B is times 4. Right? So 2 times 4 to the x, excuse me, says how many cells can he expect at hour 10? How would I get this? What do you think x represents? Hours. X represents hours. So if it says how many would he get in 10 hours, what would I do to find it? Plug 10 in. So 2 times 4 to the 10th power, and you just type it in the calculator because this is going to be massive. 4 to the 10th power.